we say this is the KCL Kirchhoff Current Law. Now basically before going to start with the Kirchhoff Current Law, we should know what is the node. Current basically once it is passing through one path, and if it is passing through one path, then the current is the same quantity. But if it is divided into another two parts, then the current will be the different quantity, I1 and I2. Suppose if we consider there is a one resistance, just for a practical example, one resistance here and another resistance here. This one is the R1 and that one is R2. So if current is passing here, I1, obviously the same current is passing through the R2 also. I1, same current. But here you can consider there is no current branching. So we don't consider this is a junction point. This is not a junction point or node point. This is just a simple connection. Now junction point or node point we say where there is a resistance here, one resistance here, another resistance here. This point will be considered as a node point or junction point. Here you remember this node point only the current will be divided. For the DC, for consideration of the DC, this node point may be resistance, all are resistance, and for if you consider for the AC, it may be one is the resistance, another is the capacitor or inductor, whatever may be. So now we are going to start the Kirchhoff's current law. What is the basic principle of Kirchhoff's current law? Suppose we consider a point, a node point. Here from the different portion of the circuit, currents are coming, currents are leaving, currents are coming, like that. So right now I put here I1, I2, I3 and I4. So if you check the entering current, if you remember the entering current, if you say it's a positive, then 100% leaving current it should be negative. Now this is just for your considerations. Now how we prove the circuit, because we consider an electron, it can't stay anywhere else in the conductor. So that's why whatever current is entering, the same current is leaving. So if you consider the current is entering, you can check the number of current is entering I1, I4 and I3 towards the node. This node, we consider the A node. Towards the node current is entering. So we can consider I1 plus I3 plus I4. That obviously that is equal to the leaving current. What is the leaving current? That is the I2. So this is basically the Kirchhoff's law. So if you bring all together in one side, then I1 plus I3 plus I4 minus I2, that is equal to 0. So that means the current, irrespective of the direction, the current is entering towards the node is equal to 0. So if the number of branches are more than n numbers, then we can consider In, then n equal to 1 to something, maybe here you can put any numbers, then that is equal to 0. So this is the basic principle of the Kirchhoff's law. That means the number of current entering and the number of current leaving both are equal, or you can consider the any node point irrespective of the direction, the total current that is equal to 0 in the node point. So now we're just going to start one problem. It's simply a simple problem. One resistance here, another resistance here, another resistance here. Here we put a current of 10 ampere and here is a 5 ampere. Now you have to find out the current here. How you can find it out? Here you can find it out the current I make a mistake here. It should be the bigger current because current is entering here. 15 ampere current, and now you consider this a 10 ampere current. Okay, so here the node junction is this one. This is the node junction A, and there is another node junction B. So here you consider 15 ampere is entering, and both the current are leaving. This one also leaving, that one also leaving. So how much is the current I? So we can consider the entering current 15 ampere, that is equal to leaving current 10 ampere plus I. So if you calculate this one, I equal to 5 ampere. So this is the answer. Now this is very simple for the Kirchhoff's law. If we're going to start a big problem, just make a little bit bigger problem. Here the current is 2 ampere, here the current is 3 ampere, here the current is 5 ampere. You have to calculate the current here and also the current here. How you can find it out? Now check. This is very simple. 5 ampere is entering, 2 ampere going this side. So obviously here how much current? 5 minus 2. So 3 ampere. Now again this 3 ampere and 2 ampere entering here. So this node point, how much is the total current? This path again 5 ampere. So this 5 ampere now divided here 3 ampere. So this is entering current now 5 ampere here. Now here is 3 ampere. How much is this current here? 3 minus, just 5 minus 3, you will get the 2 ampere current. Like this way you can calculate the branch current with the help of Kirchhoff law. This is very simple. Again we are going to solve another problem. Suppose this is a 3 ampere, this is a 2 ampere, and this one is a 1 ampere. Now here you will find a little bit difficulties, because 1 ampere is entering, 1 ampere is entering here, but leaving is 3 ampere, and this is also leaving, this is also leaving. This is I1 consider, I2 consider. Now how it is possible? 1 ampere is entering but leaving is a 3 ampere, but this is also leaving. This is not possible. So how you can calculate this one? You can consider this as a positive. So 1 ampere minus 3 ampere, minus 3 ampere, that is equal to I1. So what I1 you will get? I1 you will get minus 2 ampere. That means the direction is given here is wrong. The current is minus, that means the direction whatever is given is wrong. The direction it will be this side, opposite side. So this is the 2 ampere. Now here 3 ampere is coming, 2 ampere is going out. How much is this current? This is very easy. So this is 3 ampere, higher current than this current. So obviously 3 minus 2, it will be the 1 ampere. Like this way you can solve Kirchhoff's law. And Kirchhoff's law, this is the fundamentals. Means if you are going to enter for the big problems, you will find in small places we have to apply the Kirchhoff's law. Even for the previous video I show you the voltage divider law and current divider law, that is also applicable. In the next video we will going to start the Kirchhoff.
Don't forget to subscribe and put the bell icon so that the new video comes to you first. Thank you for watching.